The intensity of thunderstorms over mid-Missouri can sometimes be underestimated due to a lack of radar coverage in the central part of the state. ABC 17 Storm Track meteorologist Jessica Quick shows us how that's about to change with the help of the University of Missouri.
We do have several of these storms starting to form into little bowing segments, and that's what we're going to be watching, the leading edges of these storms, and where that little inflow notch is, we're going to be watching for the best rotation in this storm. If you've ever been through a severe thunderstorm in mid-Missouri and watched the ABC 17 Storm Track weather team when severe weather arrives, you know that Doppler radar is a key tool in showing you when the storms will be on your doorstep. Meteorologists in mid-Missouri use real-time Doppler radar data from 3 National Weather Service offices across the state, including St. Louis, Springfield, and Kansas City. Radar beams shoot at varying angles to provide slices through the atmosphere to see different layers of a thunderstorm. The farther a storm is away from the radar, the harder it is for this radar beam to slice through the middle and lower levels of the storm, where we typically see large hail, rotation, damaging winds, and even tornadoes. Several mid-Missouri towns are at least 100 miles away from a radar site, creating a lack of good coverage issue. Last summer, a confirmed tornado went undetected in Gasconade County near Owensville, solidifying the need for better radar coverage. A grant awarded to the University of Missouri could help solve that problem by giving the school a new dual polarization Doppler radar. It's part of a large $20 million project funded through the National Science Foundation. The radar is a small part of the grant that the school intends to use to study rainfall over mid-Missouri and how the changing climate affects plants. However, atmospheric science professor Dr. Neil Fox says having the radar in Columbia will be a real benefit to the community by handing over real-time radar data to the National Weather Service.
One area we want to look at is how much benefit areas like this that are kind of in between radars can benefit from having these small but high quality radars. We can look closer to the surface, so with severe weather we might be able to pick up on tornadoes that the Weather Service can't.
Fox says the goal is to have the radar up and running by late spring, and it'll be located on the university's South Farm just south of Columbia. The radar's range will be slightly shorter than a National Weather Service radar, up to 100 miles, with the best data between 50 and 70 miles from the radar site.
Hopefully it'll not only be a great research tool, but a great public safety tool.
In addition to detecting storm features in lower top storms, the closer dual pole radar in mid-Missouri will give us a better idea of what type of precipitation is falling in different areas, such as freezing rain, sleet, hail, rain, or snow.